4 years ago, Mr. Tan was 6 times as old as Sam. Okay, so in part A, we want to form two simultaneous equations in x and y. Okay. Alright, so what this instruction means is that you need to form two equations just like what we were doing yesterday. Okay, so we form these two equations based on the information that has been given. Looking at the very first one, it says that in 5 years' time, okay, Mr. Tan will be 3 times as old as Sam. Okay, so let's look at how old is Mr. Tan in 5 years in the first place. How old do you think he is in 5 years? X plus 5. Very good. Okay, so Mr. Tan will be X plus 5 years old in 5 years. Then after that, his age will actually be 3 times as old as Sam. So will be is like an equal sign equals to 3 times as old as Sam's age in 5 years time also. Okay, it cannot be that Mr. Tan grows 5 years, then Sam doesn't grow at all, right? Okay, so how old will Sam actually be in 5 years time? Y plus 5, right? So we have already learned that we don't really need to put in this time sign. I can just use the brackets and form multiplication and write it inside. So this will be one equation itself. Right? Then following from that, we look at the second statement. 4 years ago, Mr. Tan was 6 times as old as Sam. Okay? So how will we be able to form this equation? Ming Zhe, what do you think? X minus 4, okay, equals to, or what? 6y minus 4? 6 okay, 6 bracket y minus 4, yes. Alright, so this will be how we form the second equation, right, from the second statement. Okay, and this will answer the question already. In part A, which asks you to write two simultaneous equations. Usually will be asked to actually solve these two equations. Okay, so since we have these two equations already, let's label them 1 and 2. How will we go about solving these two equations? Chloe, what do you think? How will you do? What will you do? I have x plus 5 equals to 3 times y plus 5 and x minus 4 equals to 6 times y minus 4. From 1, okay, you will take something from 1. So what will you do from equation 1? X plus 5. Okay, equals to 3y plus 15, okay, then after that, okay, label this equation 3, fine, then, from equation 2, are you doing the same thing? Okay, so expand also, then what next? What will you do next? Equation 3 minus away equation 4, and that will help to find y, okay, by eliminating x. So yes, okay, we can take equation 3 minus equation 4, and that will mean that it is x plus 5 minus away x minus 4 equals to 3y plus 15 minus away 6y minus 15. 1.4. Okay, so in this thing itself, I am also doing elimination method, but I didn't really go and rearrange the terms to put algebra on the left side and then numbers on the right side, because that doesn't really matter. Elimination, the idea is to eliminate things first. Okay, so we will find that x gets eliminated. Okay, so x minus x becomes 0, plus 5 plus 4, so we get a 9. Okay, and then on the right we have negative 3y plus 39. Alright, then what's the next step going to be? Zoe, what do you think? What will the next step be? Sorry? 3y equals to 39 minus 9, very good. That gives us 30. So y will end up becoming 10. Okay, and if I were to let y equals to 10, okay, into any of this equation, alright, so let's say if I want to let it into 1. I will find that x is equals to 4. X is equals to 40. Sorry. So his son is 10 years old and Sam is, son Sam is 10 years old, Mr. Tan is 40 years old. Okay, so conclusion, Mr. Tan is 40. To your workbook, page 54. I would like you to do question 2 and also question 3. Just question 2 and 3. About 10 minutes to do. I believe you know how many legs, hours and horses have. Consistent, I'm sorry, that we all define the same thing. Okay, I want you to let x be the number of toys and number of toy owls. number of toy horses. Forming the equations. You raise your hand. Okay, shall we form the equations together then? Alright, let's pause. Okay, let's look at question 2. You see that we show a toy collector has some toy owls and horses. 30 heads and 78 legs in total. We want to find how many toy owls and toy horses. One owl will have how many head, how many legs? One head and 2 legs, right? Okay, so this one, let me just write here, 1 leg, 1 head, 2 legs. 1 head, 2 legs. Someone say owls got head? Owls obviously have heads. In fact, their heads can turn 360 degrees. Yeah? Don't you know? Okay, owls can turn their necks can rotate the 360 degrees, guys. Yeah. Then after that, horses, how many heads, how many legs? 1 head and 4 legs. Okay, so we let X be the number of toy owls and Y be the number of toy horses, right? Okay, let's focus here. Right, the number of toy owls, okay, if it is X, right, and the number of toy horses if it is Y, let's look at how many heads will there be in total. Okay, because the owls and horses only have 1 head each. Okay, so if there are X number of owls, okay, it will also be X number of heads, correct? If there are Y number of horses, there are also Y number of heads because each owl got only 1 head and each horse also only got 1 head. So therefore, X plus Y is equals to 30. Right? Then let's look at the legs portion. Okay? 1 owl got 2 legs. So if I have X owls, how many legs are there for the owls? 2x. Okay? 2x for the number of legs from the owls. Right? Then after that, how many legs will there be from the horses? 4y. Okay? together, I get this equation. So therefore, I form my equation 1 and equation 2 over here. Okay? Now let's look at question 3. Okay, so we just focus on forming the equation. Question 3, 2 thumb drives and a media card reader is $40. 4 thumb drives and a media card reader is $70. If I let X be the cost of thumb drive and Y be the cost of media card reader, okay, so in this first statement itself, what is the equation that I can form? Angela, what do you think? Very good. Okay, 2x plus y equals to 40. That is from the first statement. Okay, and from the second statement itself, Vicky, how do I form the second equation? Okay. 4x plus y equals to 70. Okay, are you feeling okay? Okay, so these will be the two equations, alright, that you will be using. Okay, so can you please continue and solve these two questions now? Different? Okay, let's look at question 2, right? So what actually has suggested is to multiply by 2 for equation 1. Okay, so that you get 2x, 2y and 60. Okay, so having 2x plus 2y equals to 60 over here. Then after that, taking equation 2 minus equation 3. Okay, so she has a 2 over here. Equation 2 minus equation 3, that will be 2x plus 4y minus away 2x plus 2y equals to 78 minus away 60. Okay, so this is fine. However, I want to point out that although our final answers are correct, this step over here is not right. Okay, should have been a minus and plus becomes a minus over here. Okay, so that 4y minus 2y is actually 2y. Okay, so you need to be careful when you open up the brackets. Okay, here notice, right? So y is equals to 9, and then after that, putting it back into equation 1, we get x equals to 21. Okay, so he has 21 toy owls and 9 toy horses. Okay. Next, let's look at question 3. Okay, final answer is also correct, 15 and 10. Okay, so what Shiwen has given us is that taking 4x plus y minus away 2x plus y to eliminate away y. Okay, and you see that over here, opening up the brackets, minus and plus becomes a minus here. So this step is correct. So therefore x will be 15, and then putting it back into equation 1, okay, we get y equals to 10. Okay, so therefore, one thumb drive costs $15, and one media card reader costs $10. Okay? Any questions? Alright? I hope that we have been doing this simultaneous equation for so many times, so many days already. Okay, you're getting better at it. Okay, and you also are improving on algebra. Alright? Let's look back into our notes, example 17. Saying that there's two numbers x and y. Okay, then after that, if 6 is added to x, value will become 2 times that of y. And in first statement, sum of two numbers x and y is actually 15. Okay, so from the very first statement, what is the equation that we can get? Good. What is the equation we can get from the first statement? Sum of two numbers x and y gives us 15. Yes, x plus y equals to 15. And then what about in the second one? It says if 6 is added to x, the value of this will become 2 times that of y. Okay, how do we form that equation? Wei Le, what do you think? Let me try. Yes, Wei Le, what do you think? If 6 is added to x, what does this part mean first? Okay, very good, x plus 6. And this value will become 2 times that of y. How do I continue? Equals to 2y? Is this what you mean? Or just 2y? Plus 2y? Then, got equation, man? Sorry? Equals to 2y? Equals to what? What does will be means? thing will be this. What does this idea of will be means in maths? If I say that maybe Wei-Le will become bus driver, okay. Yes, I know. Yeah. So you equals bus driver, right? If I say you will be bus driver. So with this idea of will be, how do you translate it here? X plus 6. This part is x plus 6, right? And then this means your y. Should it be a plus over here? That's my question. Then what should it be? It should be equals. You understand? Okay? Alright, so we get these two equations now. Alright? So we got equation 1 and equation 2. Okay? Sorry, something I forgot also just now, right? In the earlier questions, even if you do by substitution method, that's also possible. Although it may not always be easy to do substitution. Okay? So maybe let me use this example to do substitution instead of doing elimination. Right? Although elimination seems slightly easier. Okay? But in case any of you are very used to doing substitution or find that more comfortable. Okay? So if I have x plus y equals to 15 and x plus 6 equals to 2y, right? Okay? The idea of substitution is that I need to know what does x equals to and what does y equals to. Only a single x and a single y. So what I can do is that I either change equation 1 or I change equation 2. Okay? So anything up to you. Okay? If I want to do equation 1, okay, I can choose to get x equals to 15 minus y. Okay, whereby I move the y over to the right, and I have my left side only a single x. I can also change it to be y equals to 15 minus x. That is also possible. Okay, I'm just writing down all the variations first. Okay, they are possible. Right? And then from equation 2, what I can also do is I can have the 6 moving over to the right to get x equals to 2y minus 6. So these are all the possibilities. You just have to choose one of them to work with if I want to do substitution. Okay? So, right, could I erase this? So I only want to choose one. Okay, let me maybe just choose the first one. Okay, x equals to 15 minus 1. Right? So I use that as equation 3. Because it came from equation 1, I cannot use it back into equation 1. I will get back in the same cycle. Right? So I will go back into equation 2, I will sub equation 3 into 2. Okay? So I will have 15 minus y plus 6 equals to 2y. Okay? Whereby I replace the x over here. So that's why I have the 15 minus 1. Okay? You can put brackets, but in this case it doesn't quite matter. It will still open up to be the same thing. Okay, so I want to find out the value of y. Okay, I can shift this negative 1 over to the right. So I get 21 equals to 3y. And then y ends up becoming 7. Okay. And now if I were to let y equals to 7, I will ideally put it back to 3 because I already know what is x. So I'll see that x is equals to 8. So those are the two numbers. Any questions? question 5. I think we have done something similar before when we were doing the earlier chapters. I forgot which chapter is it. Okay, where we were handling fractions. Okay, problem sounds something like that. Okay, it says that if 1 is added to the numerator and denominator of a fraction, we are getting the value 4 over 5. Okay, so we need to think about it in fraction first. That in my fraction, there is some numbers on the top and at the bottom, right? Numerator and denominator. Okay, so if 1 is added to the numerator and 1 is added to the denominator, this fraction itself becomes 4 over 5. Okay, let me just put it in a very loose terms first using shapes. Okay, and then if 5 is subtracted from the numerator and denominator, I'm writing it short, the value becomes half. So likewise, there is the same fraction, numerator we minus 5, denominator minus 5. Okay, and that becomes half. But of course, whenever I'm doing simultaneous equations, I'm not using star and triangle. Okay, I'm using other form of symbols, x and y instead. Okay, so what we can do is I let the fraction be x over y. Okay, so I let this fraction be x over y. That means my star, I change it into a x. Triangle, change into a y. And that's how we form the two equations. Okay? Equals to 4y plus 1 equals to 5. No. Okay? Because eventually if I put this into this second equation, the answers don't tally. Okay? If I have x plus 1 equals to 4, that means x must be 3. But then 3 minus 5 will give me 1, right? So therefore the theory over there doesn't work. Okay? In case you fall in that trap. Right? So what are we supposed to do when we have fractions, okay, in simultaneous equations? We want to get rid of them, right? Okay? So how do we go about getting rid of them? Let's try it. How do we get rid of fractions? Sorry? Yes, okay, we cross multiply. So from equation 1, okay, cross multiply, I will have 5 times x plus 1 equals to 4 times y plus 1. Okay? And then we expand it to get rid of the brackets. And we have this. Okay, up to your choice, alright, whether you want to leave this in this format, okay, and then label it as equation 3, or you want to rearrange slightly, okay, to what you prefer. Alright, so maybe Kai-Xuan, do you want to name this equation 3 already, or do you want to do something more? Up to you. Doesn't matter. What's your decision? Leave it like that? Okay, sure. Alright, let's leave it like that. Okay. Then after that, right, okay, we do the same thing for equation 2. Okay, so here, what do we get from equation 2 when I cross multiply? 2 bracket x minus 5 equals, okay, 1 times y minus 5, that still remains the same, so we get y minus 5. Expanding this, we will get this one. Okay. Alright. So Valerie, will you actually leave this like that and name it equation 4, or will you do something more? Up to you to decide. Leave it like that. Okay. If I want to leave it like that, then Valerie, how will you solve equation 3 and 4? What method will you do? Substitution or elimination? Substitution or elimination? Elimination, what will you do to do elimination? know both are acceptable, right? Up to you to decide. Both are correct answers. You just have to choose. What do you prefer? You don't have a preference? Make a decision. I'm not asking you to marry the simultaneous equation. Sorry? Okay, you want to do substitution, alright? Then how to do substitution? We want our objective to be y or x. How? We have 2x minus 10 equals to y minus 5. Is there a way that we can change this before naming as equation 4 for us to do substitution? Yes, Hayward. Put what? Put x and y together. So this one, the y put together. Okay. But if I want to do substitution, how? Okay, if you want to go and try on your own now, you can. Alright? But you want to try it on your own? Yes? No? Who wants to try on your own now? Raise your hand. Who wants to do it together? Okay. Then who is going to decide elimination? Okay. Then who wants to do substitution? Okay. So looks like people really prefer elimination. Okay. So let's do elimination then. Although honestly I thought that substitution is slightly easier. Never mind. Okay. Because elimination, okay, let me just share my thoughts now, okay? If I were to choose elimination, right, okay, I will need to multiply by 4 over here to get rid of the y, okay? Or if I want to get rid of x, right, then it's more complicated, where I need to times 5 over here to get 10x, and I need to times 2 to get the 10x, then I can eliminate. Right? So if I want to get rid of x, it is more steps. Getting rid of y is slightly easier. Okay? If I do my substitution, right, I simply need to actually just move the negative 5 over to the left, and I get 2x minus 5 equals to y. I already got a single y over here, right? It's just a few steps away to get y, and then I put it inside here, and then I can solve already. Okay, that's my thoughts on substitution now. Okay, but since you want to do elimination, right? Okay, so elimination. Let's do substitution now. Is it okay now? Okay. Okay, you want to do elimination, can go home and do it yourself. What is substitution? Substitution is where I have a single x or a single y, and then I am given something for that value, and then I replace. Substitution is the replacement one. Okay, so now I can understand this in this manner. They are the same. Okay, so I substitute equation 4 into equation 3. So I will have 5x plus 5 equals to 4. I replace the y with 2x minus 5. Okay, so I replace this y over here with the 2x minus 5. That's why I get this. Okay. Expand, simplify. And we see x equals to 7. Okay. Then after that I need to find out what is y. So y equals to 9. Does this answer the question? Yes? No? What does the question want? So is this answer ready? Not yet, right? Okay, so make sure you find the answer. So the fraction, what would it be? What is the fraction? Negative 7 over 9. 7 over y. 7 over 9. That is a fraction. Already, I really encourage you when you do a revision is to redo these examples, be it in whatever elimination or substitution method that you decide to do, and then check whether you get the correct answer, correct same value or not. Okay, that's how you go and practice. About value placing numbers, okay, when you learn in primary school. Okay, so it says that the sum of digits of a 2-digit number is 8. For example, I'm looking at the first statement. Okay, so from the very first statement, right, an example will be if this number is 45. Okay, if the number is 45, this is a 2-digit number, right? The sum of the digits will be 4 plus 5, and that is 9. So this is the sum of digits. That's what it means. Okay? Understand? Then after that, looking at the second statement. Okay, it says that the digit in the tens place is A and the digit in the ones place is B. So 45. That means the digit in the tens place, if you recall, which one is in the tens place? 4, right? Okay. So this is the tens place, and this one is in the ones place, right? So the one in the tens place is A, and the one in the ones place is B. Okay. So that is how it labels. But of course, in algebra, I put 4 and 5 together. It means 45. But if I put A and B together, it doesn't mean that the number is AB. Okay? Because this actually means A times B. Right? So it's a different meaning when you put it together in algebra and putting it together in numbers. So there's a different meaning. It's not 4 times 5, right? This way is 45. Okay? So they gave you this explanation over here. It means that the 2-digit number can be written as 10A plus B. Okay, so the number over here, I cannot write it as AB, right? I write it as 10A plus B because if looking at this example, 45, if the A is actually 4 and B is actually 5, this makes sense and tell us that it is 45. Agree? Okay. So with this understanding, looking at part I, we want to write an equation in terms of A and B. Okay, so this equation in A and B, right? Okay, or two-digit number 8. Okay, so if the digit is A and the digit here is B, so to get the very first equation is simply just A plus B equals to 8. So that's the answer for part I. Okay. And the number is subtracted from the original number, result is 18. Okay? We can note that the original number is 10A plus B. Let me just write that down first. Because A and B are single digits, okay, A and B are single digits. Supposedly in this example representing 4 and 5, but the entire number that comes together is 10A plus B. Okay? And then if my new number, when the digits are reversed, okay? It means that how it looks like is that I have a B and an A instead of AB. Original number is AB. I'm drawing boxes. Okay, as though it's placed side by side. Doesn't mean multiplication. Okay? So if the digits are reversed like that, B is the number itself. That means that the digits, the new number, okay, will be 10 times of the value of B plus A. Okay? Original number 10A plus B, new number 10B plus A. Any questions? Any questions? We understand? Yes or no? Sure? Yeah? Right? Then now we want to form that equation because it says that the new number is subtracted from the original number. Okay, so that means I take the original number 10A plus B, subtract out 10B plus A. Because it's the new number subtracted from the original number. So start with original number, minus away new number. Okay, and this results in 18. So this is how the second equation is formed. But I can simplify this. And I get 9A minus 9B equals 18. Any questions? So I got my first equation already and my second equation. Okay? In part 3 we want to solve and then determine what is this original number. So what we can do is that if I want to do elimination, from equation 1, what will I multiply by? I'll multiply by 9, right? So I got equation 3 over here. So the original number is the number 53. Okay. This question is definitely a stretch. I know that it's slightly difficult to comprehend. Remember homework due, then we will continue with some more problem sums. Okay. Yeah, I would also like you to bring a graph paper for the next maths lesson. Okay, bring graph paper to class and also bring long ruler. Alright?